The IBM PC came out in 1981 with the advent of the 5150. That particular model used lots of different electronics that were kind of industry standard at the time. The follow-up PC was very similar and was called the XT. That machine is the machine that I'm going to talk about today on Al's Geek Lab. Now, the reason I got a video about it is because I started work on the ISA PicoMem, which is an expansion card. And that was in my last video a few weeks ago. So it's a great card, but unfortunately when I went to test it on my IBM PC XT. Kind of close to my heart, that particular machine, because it's come across countries with me, it's come with me through all of my life for decades now. So when I went to switch that machine on and found that all of a sudden it wasn't working and it went pop and made a smell that wasn't so great, I was a bit concerned. I thought, am I going to be able to fix this? It is from, the mid-80s at least, so that's a bit of an issue. For me, I was a bit downhearted. So I got as much information as I could about the machine. I looked it up on -0 degrees, great website by the way if you haven't been to that, and tried to get a little bit handy with the multimeter and the soldering iron as well. So in this video you're going to find out whether I was successful in repairing said PC, the IBM PC XT 5160. Stay tuned, that's all coming up here on Al's Geek Lab. This video is sponsored by the very wonderful people at PCBWay. PCBWay are the leading electronics and prototyping manufacturer. If you've got an idea, you can use PCBWay to turn it into a reality. PCBWay can build PCBs from just $5 and build them for you in around 24 hours. Now, what I really love is that for people that suck at using a soldering iron, like myself, you can upload your PCB file and have PCBWay assemble it all for you. PCBWay also do 3D printing, CNC machining, sheet metal fabrication, injection molding, and so much more. They are widely reputed by us in the retro computing community as being the go-to supplier of your PCB needs. So if you've got an idea for an electronics project, why don't you give PCBWay a try at PCBWay.com? After all, that is the PCB way. We thank PCBWay for sponsoring Al's Geek Lab. Now, let's get back to the video. The classic IBM 5153 CJ monitor paired with the IBM PC XT, or 5160 as IBM called it. It was the successor to the original IBM PC, which came out in 1981. This one came out in 1983. Not a lot changed inside it, a little bit bigger of a power supply. It also had a hard drive instead of 2 floppy drives, and it had 8 ISA bus slots instead of 5. But basically from this machine onwards, right the way kind of through to modern day, this was kind of the spec of the case of the computer which we call the PC. So let's get it apart and, well, see if magic smoke comes out of it first of all, I guess. As you can see, I've already made a handful of upgrades to this machine over the years. The card on the left there is a turbo. Actually, that little switch there you can just about make out, that's a turbo. I also have the XT IDE CF card, or the compact flash adapter, which allowed me to have up to 2 gigs, I think, of storage. There's also a memory expansion card. You can see that I wrote there MEMEXP. Then there is a serial port and an ISA 3COM network card, followed by a sound blaster, and then finally an EGA card. So there's quite a lot of expansions in this. This one has been left quite some time on its own, and well, these machines have a habit of not liking sitting there doing nothing. So let's just take off the lid and see what happens when we switch it on. Okay, here goes the moment of truth. Let's check for smoke. Well, it didn't start, so that's that's really not a good beginning. The power supply there span up for just a moment and then switched off. So that usually means there's a short somewhere, which is not great. Let's just give it one more try. Yep, even worse. The power supply almost didn't start up. I think this is probably the second time when I've had to diagnose one of these boards. And the first time was many, many moons ago. And what typically seems to happen is the tantalums on them go bad, they short out because eventually, well, like most things, including myself, they get old. So what I'm going to do is I'm going to take all of the cards off, all the expansion cards, I'm going to take them all out. And then maybe the machine might start up because maybe the problem is with one of those expansion cards. That's a big maybe. Usually it's not, but let's just try taking all of those out first of all. Just in case you were interested to know which cards I had there, I had quite a lot from Monotech PCs, which is from here in New Zealand, actually near here in Wellington, which is wonderful. So yeah, this is the XT IDE Deluxe from Monotech, which has a 128 megabyte compact flash in it. Also from Monotech PCs, I have the micro RAM, which basically allows you to get up to 960 kilobytes potentially of RAM, and that's through using the upper memory block and so forth. So that's a pretty cool card to have. Then there is another Monotech card, and that's this one here, which is called the Deluxe floppy. It does a couple of things. Basically, it's a floppy disk controller, but also has a serial port on it, a 9-pin serial port there. So that's pretty handy. And then the other two cards I had in the system was this pretty good 3COM 3C503, which is actually a 16-bit card but works in an 8-bit bus as well. And then finally the good old Sound Blaster CT1350B, which is the Sound Blaster 2, the genuine card. Alright, so that's all the cards out. I flick the machine on and, well, see if it fixes the problem. I am thinking no, but let's give it a shot. So the only card I have remaining in there at the moment is that 286 daughter card, if you like, because it's basically got the processor on it. So without that, I have to switch over the processor. So if that card has a fault, then I have to take that card out and put the original 8088 back in. But let's switch it on. Yep, still dead. Okay, next I want to check to see if either that 286 card is failed or there's something wrong with the power supply. Now, because the power supply fan moved just a little bit there, I'm thinking it's probably not the power supply. So it's either this card here, the CPU card, or it's something on the motherboard itself. But I'll test that next. Now, one of the things you can do before I take this 286 card out is also take the 12 volt rail off. So the AT power supply, which is this tile of power supply, I'll just take the power cable out just in case I short anything out. There's two kinds of power cable. They can be put round the wrong way. You don't want to do that. So the way that I always remember it anyway is back to black. So the black cables go in the middle there. They never go out of that way. So if you put them round that way, sort of you're red, you're dead. Kind of the red cables go together, or it's reddish. Back to black. That's the kind of way that I always remember putting them. But if I think if I just look at the voltage key down on the side there, so the one saying P8 1 2 3 4 5 6 I believe is 12 volts. 3 is plus 12 volts. P8 4 is minus 12 volts. So if we look at these two cables, these two connectors, sorry, one of them says P8 and the other one says P9. Now if we look at the one that says P9 on the key, you can see that it says plus 5 and negative 5. So this runs purely the plus 5 volts, or the 5 volt rail, I guess. This one here, the 12 volt rail. So what I'm going to do is I'm going to leave the 12 volt rail off. My understanding is that most of the system itself, I'm pretty sure, ran off of 5 volts, not 12 volts. There was 12 volts for some other stuff. So what I'm also going to do is I'm just going to disconnect the power from the floppy drive, because I've not actually done that yet. There we go. Alright, nice. So hopefully there's nothing on the board that's going to draw 12 volts that I need it to. So let's see if that makes the machine spin up, because if it does spin up, obviously we can't use the machine like this, but if it does spin up, then that would indicate to me that it's one of the 12 volt tantalums, or something on the 12 volt rail. And anyway, the 12 volt tantalums are fairly distinctive. Let's plug in the power. There we go. And alright, so instantly, you heard the speaker there, it's unmistakable. Instantly we can tell that, hey, we got power to the system. So what that's telling me is that there's nothing wrong with the power supply. I'm pretty sure of that, unless there's something wrong with the 12 volts stuff inside, but I don't think it really descends from that. It just gives out 12 volts, I think. But anyway, I think the power supply is good. I think what the problem is probably something on the motherboard itself. So we're looking at a short here on the motherboard somewhere. So that means that we probably want to take out the motherboard and check for shorts. So now we believe that it's something on that 12 volt rail, and we think that it's probably one of these capacitors, or the tantalum capacitors to be precise. It's about time we got this motherboard out of here. And the way I did that, obviously take that floppy disk drive out first, and to save time on camera, there's 2 screws, 1 and 2 over there. Obviously make sure all your expansion bays are empty. And the other thing to make sure of is that these little clips don't get broken. These are really annoying little clips, to be honest with you. They're a bit fiddly, but once you manage to prise them all up, you can push the board up and get it out. So I'll do that off camera right now, and then we can get to testing these tantalums. Now I used a combination of needle nose pliers and also some chip removers to get those last sticky little clips off the motherboard. I'm also going to use this power supply out of the case. This case is a rather bulky case, as you can see. It's always nice to just work on things with a bit more space on the desk. Power supply just pushes forward on its little rails and then out like that. This power supply is from a fair few years ago by the looks of it, 130 watt power supply, so definitely more powerful than the original, I think, 80 watt power supplies which came in the original IBM PC. This one gave us enough juice to provide power to extra hard drive Z, and of course on the side there you can always see what output they're giving, which is pretty handy. So whilst I was doing my last minute preparation tests to show you the next stage, something went crackle. So I just switched on the power supply just for a second, just before I was about to demonstrate the test from the multimeter, and then something went crack. I think it was this tantalum right here that went crack. Now, cracking is never good, because it can do damage on the 12 volt rail, for example. So if power's traveling down that 12 volt rail, and basically that just jumps out through past that capacitor and then onto the rest of the motherboard, then you could basically damage the rest of the motherboard. So hopefully that's not happened. There is definitely a sort of smoky smell, so there is definitely something that's not working here. Now, whether that's a tantalum or whether that's something else, I don't know at this point in time. So we just need to find out what that dead component is. So it's time to check those tantalums. And where I'll start first is actually on the power supply side. So basically where the power enters the system first, and then I don't know where it goes after that. Probably, well, if it's the top 12 volt rail, I think they're sort of this way and then maybe this way on the outside. So you can see the large tantalums and out, so those are the ones that I'm going to measure. So with my multimeter set to ohms, and basically we just want to check for continuity. Obviously that means that there is a shorting those connections out. Right, so if you hear that, it basically means there is a short which is not what we're wanting. We want to see some form of resistance, and we want to see, you know, reasonably high level of resistance to show that they're actually doing the job. The issue with these tantalums as well is that they're not like our usual friends, which have two legs. So here's another capacitor here, which has just standard two legs. IBM chose to use these three-legged ones. So when you replace them, you need to make sure that you're replacing them with in the correct polarity position. So that's just a little gotcha. But you may see, I'll probably just hold up the board in fact to just show you, just so you can clearly see those three legs on some of those tantalums there. That one there where my thumb is a good example of the three legs. So just so I'm being clear that I'm not doing the two outer legs, I'm doing the inner one and the outer one on these, because the outer, if you measure the two outer, you just get a short. So let's just go from one side of the board to the other. Hopefully you can make out what the multimeter is saying, and I'll just crack on with doing those. So as I say, the first one I'm going to do is down by the power side. So I think positive is the one in the middle, or is it the one on the outside? Now straight away that looks like a short. I'm going to say that one is suspect. So with anything suspect, I'm going to put a little, in fact if I look at it carefully, there's actually a little sort of nick there which I can see and I can sort of feel as well. So that one might have gone bad. Off to a rearing start. Let's check this one here. Yep, that one might be okay, despite it being big and ugly and dirty. Now just go down to the bottom of the board and work my way around. What about this big guy down here? Getting 450, so that's possibly on the low side. We got 500, 600 on that one. So if we're getting, oh no, it went up to 597 there. Hold on, maybe I was just 600. Okay, that one's fine then. Okay, let's go to this one on the beside the memory banks. So again, starting off at 400 odd. Okay, let's just try this one. Yep, that looks good. Now let's go over to these ISA slots, or ISA slots, whichever way you want to call it. Yep. Yep. That's a value there too. Yep, that's a good one. I am getting something out of that. Don't think I'm getting anything there on C56. Absolutely nothing. It is a bit bulgy on the top. I don't know, it's probably impossible to make out on camera. There's a little bit of a bump on C56 there, and that might indicate that it's blown or it's about to blow or something like that. So I'll put a dot on that one as well. And then so now we'll go into, I think I tested these ones already, so I'll test this one here. Yep, that one's good. Okay, so I believe that's me tested all of the large tantalums. So because I don't know if I can trust this power supply as well, I think the best way to try and figure out whether it's dead or alive, rather than rely on what it was doing with that definitely dodgy motherboard, is plug it in. And the reason why I've got this old hard drive here and this floppy drive from the XT, by the way, is because these power supplies, most of them, need a load on them, so they need some sort of thing to draw power from them before they'll actually start up. Otherwise you'll just see that little quick spin of the fan and then they'll stop. So let's stick the power in and see if it does anything. Now the floppy drive is from that failed machine, so it is possible that a tantalum may also be faulty on this, and so I will remove the floppy drive if nothing happens again. But let's have a look. Well, that's good. The power supply is fine. So yeah, it's all about that motherboard. There are definitely a few shorts on that motherboard. We can see that there's tested caps over here, in this area, this one here, and this one here right beside the power line itself, which is probably where it comes in. Everything else seems to have tested okay, but that's 3 caps. Then these little smaller ones, what I didn't realize is that they're probably on the 12 volt rail as well, these little ones. And my understanding is they're actually quite reliable. So I don't want to replace those unless I absolutely have to. There's actually quite a few of those types on the board as well. But my guess is they're okay and they're just going nowhere, so we probably don't need to replace them. So this one here, this one here, this one here, they're faulty, and there's a whole bunch of them around there as well, which will probably go bad at some point. It might take years for them to go faulty. These motherboards are incredibly thick. They have a really strong ground plane on them, which whilst is, you know, a testament to its build quality. This board was made, I think, well, it comes from the era of 1983. I think this board in particular, these are the original components from 1985. I think this board was an 85 one. All the way from where I used to live in Scotland, in Greenock. So yeah, it's definitely about time that things started to fail on it. I'm amazed that it's lasted as long as it has. But again, that's testament to its build quality. And yeah, and of course Scottish engineering, since it was built in Greenock in Scotland. No, they're all the same, regardless of where they were built, whether they were built in, I think, Armonk in the New York area, or indeed in Greenock in Scotland. Perhaps they were built in other places as well, but those are the 2 areas that I know of their building. The thing about these motherboards is if you don't use it, you'll lose it. And I think that's quite commonly found out. So what do I mean by if you don't use it, you'll lose it? Well, these caps have a funny habit of dying when not in use. And as they get the first power, a bit of power, they often fail within a few seconds. I've read that on -0 degrees, it's not my words. And so if you use the motherboard, or the PC that is, regularly, then you probably won't have a problem, or it might take a lot longer to manifest in a particular problem. So I left this XT alone, sadly, without use for, I don't know, at least a good 6 months, probably, maybe longer. And as a result, it's probably got a little bit sad and decided that no, it's no longer any use to anyone. And yeah, of course, the tantalums have failed. So yeah, if you have old machines, look after them. Keep using them, otherwise they might die. So that's the moral of this story. Here's a little montage first off showing the removal of one of the bad caps, that's C68. Sorry for the shaky camera work. Turning the board round to the other side, replacing the other 2 caps there as well. Once all the caps had been replaced, it was time to put everything back on the test bench and see what happened when we powered the board up. Okay, let's put it all back together then, shall we? I have with me the box, I have with me the motherboard. Let's take it out of there. Let's have a good little look at it before we go anywhere. So those 3 tantalums that were faulty have now been fully replaced with alternative caps. So they look pretty good. Nice small caps. And what you can see is that they have two legs. Most of the modern tantalum style capacitors have two legs, not the three. And that's fine because there's only a positive and negative on the caps which were on the IBMs in the first place. So you just have to make sure that the polarity of the caps are the right way round. So now that the caps are replaced, let's go ahead and get this motherboard introduced into a test situation first. So let's do that with a bit of jankiness. Jankiness, my favourite word, right? I am going to put power supply over here so we can see everything happening in real time as it blows up. I'm joking, I really hope it doesn't blow up this time. Get a VGA card in it for your viewing pleasure. There we go, stick that in. Heck, why don't we even stick a keyboard in? Not that we really need it, just to make sure this all fires up. Let's get the power cord in here. Monitor is on, I think. So yeah, with any luck, this old baby is going to hit 88 miles per hour. Well, the CPU, the power supply is spinning up. And I actually forgot that this board here doesn't have doesn't have a CPU in it, because I have that daughter card, the 286 daughter card. I'll just bring that into view there. You can see the 286 daughter card there with the Siemens processor on it. So this gives us the 8088 here on this sort of riser card. That's a V20 specifically, but same, right? And then we have the 286 over there, and you can switch between them with this. So I believe up is on for the 286. Now comes the tricky bit actually. It's getting these pins, which are quite brittle. They're not great actually. These are gold pins, and getting them into the motherboard slot. Now I believe this one works in slot 8, so I'm just going to plug it in. Let's check it out. Now that we've got the Orchid card in and we've got a VGA card in, let's see if we can get some life out of this thing. Monitor light goes on. Yeah, beauty. Now there's lots of errors, like a 40,000-00201, but I think that might be because it doesn't have enough memory, because I'm only using the 256K which is on the motherboard. So let's switch it off, put it on the memory card, and let's see if we still have that 40,000 one. That's a memory error if I'm not mistaken. The 601 is something else. I can't remember what that is. Maybe the lack of a floppy disk drive or anything to boot off. So let's put the memory card in and see what happens. Where did I put that memory card? In my big sack of bits. The smallest of all the cards that I have for this machine, the Monotech PC Micro RAM. So that's in there now. Let's have a look and see if that memory error is still around. Okay, so I've got those blooming little risers, I don't know, doodads. I've got the doodads off the motherboard, and I think this is the best way. I think this is the way to do this. So you slot them all in first, and then you put the board in on top of them. It's fiddly. These really suck, these things, because they come out pretty easily as well, you can see. So they're not great. Awesome. Alright, now just 2 screws. I'll just give them 1 turn. I don't want to push them in too hard. Let's get the boards back in. So first of all, going to start with the CPU board. And it does work in slot 8, which is great. You can see how it's assembled. The 8088 usually plugs into this socket on the motherboard, and it's now just got this little riser cable, which is pretty precarious. That's the drive adapter. Never get your pins round the wrong way. It can spell disaster for some drives. This is the 3COM 3C503 network card. It's a 10 base T 16-bit card, which also works in 8-bit mode. This is the Monotech XT IDE Deluxe, the compact flash card reader. I'm going to put in Sound Blaster next. And the last thing for this machine is the RAM expansion. I'll just check the jumpers on this guy. Pretty sure I want to give it some expanded RAM, or not expanded RAM, upper memory. So in this card we can enable the conventional RAM with this first jumper block. So all of this would be 640k. Don't know if you can make it out, it actually says which area of RAM. Now we already have 256k on the motherboard. So in this case we want to go with the 256k to 320 and 320 and 384 and so forth, all the way up to 640, and that's why these are all switched up. With this is all the memory up to 1 megabyte, or A000 through E000, or sorry, F000. So I think there is some that we can actually enable even if we're using a EGA or VGA card, but it is limited. So I think in this particular case, if we enable B0000, this one, and probably D000, which is this one, and E000, which is this one. It just sits in there. I've got a blanking plate that just, I say memory expansion on it just to remind me what's in the machine when I look at it from behind. Right, okay, that's everything then. Let's plug it in before I screw everything together. Let's see if it beeps and posts, and I'll put a keyboard in this time. Okay, moment of truth. We have power, we have VGA, and we should have a count up here of 640 kilobytes. It's looking good. Okay, well, it got a long way, got all the way to boot, but it hasn't found the compact flash. I wonder why that could be. As you can see, it is now evening, which is pretty much all of these projects. But hopefully, now that I've clicked the clicker, this thing's going to work. I hope. Here we go. Yep, it's looking good. Let's get that 640k, please. And then let's get into DOS, please. And then it'll almost be time for getting this thing back together. Found a CF card. And it's booting! Yes! Wonderful. We are in. Let's get this thing closed up. Well, there you go. That's how we fix the problems of the old 5150 and the 5160, the IBM PC and the XT. A lot of the times it comes down to simple aging tantalum capacitors, and they can be easily replaced, and usually they don't blow up too spectacularly that they cause massive damage. So don't be afraid to pick out the multimeter, have a look and see what you can get to with the soldering iron, and you'd be amazed at how simple sometimes these repair jobs can actually be. It's definitely well worth your time considering the cost, especially if it's a real IBM part. Anyway, I hope you've enjoyed this video. If you have, please press the subscribe button, hit the notification button as well. Really love for that, because it really makes a difference. All the effort that we put into these videos, us YouTubers that is, it really lets us know that you're enjoying the stuff that we're doing. So press that thumbs up, hit the notification bell, press subscribe, all the things, leave a comment, blah blah blah. That would be cool. If you didn't like the video as well, do let me know. Let me know what I can do to make things better, of course. If you really like the video, then head over to Patreon, patreon.com/alsgeeklab. We got lots of early content there, no ads, early access material, extra bonus stuff. It's all over there, so check it out. You know, subscriptions are like $3, so why not? Why wouldn't you? Anyway, thanks very much for watching. I'll be back on the channel in the new year now. It's coming to the end of the year, so thanks very much for watching in 2024. If you've just joined us on the channel, then stay tuned for lots of other great stuff. There's some other great content as well. Check out the other documentaries that I've done over the last year or so, and other stuff as well. But anyway, that'll be it for this one, so take care, have a great Christmas, have a wonderful new year if I don't see you before then, and be excellent to each other. See ya!